All right, ladies and gents. So let's go ahead and get started with our notes. So we're doing 4.2 sines, cosines, and tangents. Our objective for today is that students will be able to use a unit circle and describe its relationship to the number line, evaluate trigonometric functions, use domain and period to evaluate sine, cosine functions by completing our activity. Okay. So our main idea here is we're going to be evaluating trig functions using domain and period to evaluate sine and cosine functions. So you guys remember that over here we have our unit circle, and we're not necessarily going to bust out our unit circle right now. Okay. We're just understanding how our unit circle connects to sine and cosine, okay, and tangent. Well, if you remember our unit circle, it's called a unit circle because our radius is a unit of 1. Okay, so our radius is a unit of 1 here. Now, when we're given our theta, we're looking for sine and cosine using our theta. And usually, right up here, where the radius of that terminal, okay, the radius of that's the terminal side of our angle theta, it intersects our unit circle. That's where we get our point, which is x comma y. But in algebra 2, we talked about the fact that cosine always represents the x value and sine always represents the y value. Okay. So if I essentially know, okay, if I know my theta and I know my unit circle here, and I know that these values are my x and my y, I can essentially find my sine and my cosine values, okay, where sine of theta is equal to this value here, which is essentially y, okay? And then my cosine theta is this value here, which is essentially my x value, okay? And then tangent stems from sine and cosine. Tangent comes from having sine over cosine or y over x. Okay, so my tangent of theta is always the ratio of my sine over my cosine. Okay, so if I know my sine and my cosine, I can easily find my tangent value. Okay, now how are we going to use this to find values? Okay, without busting out our unit circle. Okay, how are we going to actually find our values without actually taking out our unit circle? Well, sometimes we remember our unit circle, and sometimes we're just going to use our calculator for our knowledge, or we can just do our SOHCAHTOA. Do you guys remember SOHCAHTOA? Okay, we have sine is opposite over hypotenuse. That's so. Cosine is adjacent over hypotenuse. That's ca. And tangent is opposite over adjacent. That's our TOA. Okay, so SOHCAHTOA. And we can use that with our theta if we needed to. A lot of times we can just remember our unit circle if we need to. The key is that we need to make sure our angles, okay, are positive and between 0 and 2 pi or 0 and 360 degrees. Okay, so we want to make sure that our theta is positive and that theta is between 0 and 2 pi or 360 degrees or 0 degrees. Okay, so that will help us. If we have a theta that is not positive, or if we have a theta that's not between 0 and 2 pi in radians or 0 degrees and 360 degrees in degrees, then we need to do what we learned in I believe, was it 4.1 with our periods and rotations. Okay, and we need to make sure that yes, 4.1, sorry. We need to make sure that we make it positive in between these two numbers here. Okay. All right. So we want to evaluate 3 trigonometric functions at each given angle. So we're given that theta is pi over 3. Okay. We're given that theta is pi over 3 here. And pi over 3 is going to give us an angle that is about, I believe, so pi over 3 in our unit circle is about here. Okay, so then our theta will end up being somewhere like this. So we'll have our right triangle here. And our theta is going to be right here. So this is going to be my pi over 3 angle. Okay, this is 1. And I need to know my x and my y here. Okay. I need to know my x and my y. So if I use my SOHCAHTOA to find sine, right, I have my opposite, my adjacent, and my hypotenuse, then it would be y over 1. Okay, so sine of pi over 3, that's y over 1. Okay, or I could just do y here. So I have sine, making sure, so really quickly, let's talk about how we make sure our mode is in the correct, correct setting. So we need radians here, right? Because we're talking about pi over 3. So radians here, we're going to go to mode in our graphing calculator. Okay, and when we click on mode, we have all of this. And notice mine is not on radian because degree is highlighted here. So I'm going to go down, I'm going to go on radian, and I'm going to press enter at the bottom of my calculator right here. So when I enter, notice now my radian is highlighted. So I'm in the correct mode now. Okay, I'm in the radian mode because that's what I'm using. Then I can do sine pi over 3, and my pi here is right over here above the caret. So, and it's in blue. So I'm going to do second pi divided by 3, close parentheses. And that's going to give me 8666666 something. 866025403. 8. Okay. But if I remember that in radians, right? I remember that in radians, I believe that is square root of 3 divided by 2. Yep, the same thing. So we have the square root of 3 divided by 2 here. Okay. If you have a scientific calculator, it might actually give you the exact value. Okay, square root of 3 divided by 2. So you want to try to keep it exact as much as possible. And that way, you know, if you remember, most of our values here are either square root of 3 over 2, square root of 2 over 2, 1/2, and then 1 and 0, right? And then you have the negative versions of those. So you want to remember, right? So over here we have the square root of 3 over 2. Hold on. Right? You have the square root of 2 over 2. You have 1/2. Of course, you have 0 and 1. Those are pretty much the values of these exact angles here, right? So like pi over 6, pi over 4, pi over 3, pi over 2, that kind of stuff. So you want to pay attention to that. So if you want to do cosine of pi over 3, now we're going to do cosine of pi over 3. And that gives me 0.5. 0.5 is 1/2. So that's going to be 1/2 here. Okay. So now that I have sine and cosine, okay, to get tangent, I put sine over cosine. So I'm going to put the square root of 3 over 2 divided by 1/2. Yeah, I took that straight from here. Square root of 3 over 2 over 1/2. well, this is fraction divided by fraction. So we can do, it's the same thing as having square root of 3 over 2 divided by 1/2. Okay, so I can skip, remember that? Change, flip, skip, change, flip here. This cancels and this cancels. And I'm left with the square root of 3. So tangent pi over 3 is equal to the square root of 3 there. Okay, and we can simplify it that way. Let me zoom out. Okay, so this is a combination, like we can definitely use our calculator, but it's a combination of using our prior knowledge of the unit circle, using our calculator, and kind of just working backwards. So yeah, I know it's a little bit non-exact, right? But we are combining some of our prior knowledge here of the unit circle and the radians and such. Okay. Okay. So for our next example here, okay, we have our theta equals negative pi over 2. Okay. That won't do. And because of, well, here, why don't we try this out? Okay. So if I have sine of negative, okay, negative pi over 2, I get a negative 1. Okay. How does that happen? Why is it a negative 1? Pi over 2 itself in the unit circle is up here. That's pi over 2, right? But this isn't just pi over 2. It's negative pi over 2. Okay. So in reality, that means that I went this way, right? And negative pi over 2 stops there. And this is actually positive 3 pi over 2. So if I wanted to figure out the positive angle here, right, I'm going to add 2 pi to it to figure out the positive angle. Well, 2 pi, put that over 1. I need common denominator, so I'm going to multiply top and bottom by 2. So this will be negative pi over 2 plus 4 pi over 2, which gives me 3 pi over 2. So the equivalent angle to negative pi over 2 is 3 pi over 2. So if I find sine, cosine, and tangent for 3 pi over 2, those values would be exactly the same as negative pi over 2. So if I were to put in sine of 3 pi over 2, I would get the exact same value here, negative 1, right? So you find that equivalent angle and you go with that. So negative 1 here, and then cosine, and I can put in 3 pi over 2, or I can put in negative pi over 2. So, hold on, divided by 2. Okay, cosine of 3 pi over 2 is 0. Okay, so now I do sine over cosine for tangent. So this is going to be negative 1 over 0. I can't divide by 0, right? That's impossible. So this is going to be undefined. Okay, tangent will be undefined. Now, if it was 0 over negative 1, that would just equal 0. But you can't divide by 0. Put a little note for yourself here. Cannot divide by 0. Okay, just in case we forget from time to time. Okay, let's flip it over. First things first, though, any questions so far? Let me clear the participants window here. Can I get a yes for I'm understanding things so far? A no for I have some questions, I'm unclear, I'm kind of stuck. Okay, thank you, Erin. Thank you, Lumeria, and thank you, Nick, for your responses. Those are the only 3 people I have received a response from. Oh, and Will, thank you. Let's see. Thank you to Ariana. Thank you, Juan. Thank you, Will. I also received responses from you guys. Thank you, Zahn. Okay, would like to see a response from V2, from Oswaldo, Kai, and Juan, please. Thank you, Anthony. Let's see here. Okay, thank you, Juan. It doesn't have to be yes. It can be no as well if you're confused or if you have a question. Okay, Juan, I saw yours and then it disappeared. There we go. I see it now. Kai, Wally, V2, anything? Okay. If you guys are putting it and it's disappearing, write it in the chat. Okay. See, I see it, Wally. Thank you. Okay, thank you, V2. Yeah, I know this whole update thing has really thrown us for a loop here. Okay, good so far. Let's flip it over. So this is now talking about domain and period. Okay, so for when we talk in 4.1, we saw angles that had like 1920 rotations in them, and we dwindled that down, right? We subtracted or we added, it was negative, until it came down and we found the equivalent angle, right? That was between 0 and 2 pi, or 0 degrees and 360 degrees, depending on what mode we were in. So what we were really doing is we were essentially bringing down the rotations, right? Well, when we talk about graphing sine and cosine, that's essentially equivalent to talking about the period of sine and cosine. So when we talk about period, right, we're talking about in the graph of sine and cosine, one period is one complete movement of the graph. So for sine, that looks like this, right? For cosine, let me see if I can grab another color here. For cosine, that looks like this, right? But the interesting thing is that each one completes its one cycle from 0 to 2 pi. So every 0 to 2 pi, it repeats its cycle and it just keeps going, right? So every 2 pi. So when we talk about our periods in for sine and cosine, right, for those functions, we're talking about essentially one full 2 pi, one full rotation, essentially. Okay. So our domain for sine and cosine is all real numbers. That's really important to remember. Okay. Domain is all real numbers. And our range for both of them, notice that they both hit the same peak. Okay. And I went a little lower here, but it really shouldn't have. They both essentially hit the same low, which is down here. Okay. So their maximum is 1 and their minimum is -1, right? This is for our parent functions. So our range for both of them is sine is less than or equal to 1, but greater than or equal to -1, because all the values are between 1 and -1 here. And the same thing for cosine. Okay. Now, as I was saying, the period is how long it takes for the function to repeat itself. Okay, so for a function to be periodic, then we need to be able to say, okay, if I take theta and I add it to a constant number, then it's going to be equivalent to the same thing as theta. Okay. So for example, for sine and cosine, if I take sine of an angle and I add 2 pi n, n being like the number of revolutions or the number of repetition, okay, the number of repetitions there, or the number of revolutions, right? So if I take theta and I say plus 2 pi n, so let's say I have 10 repetitions or 10 repeats, right? So it would be like 1, 2, 3, 4, 5, and so on and so on, right? Um, and however many 2 pi's that I want, it doesn't matter. It's still going to equal sine of theta, the original angle. And the same thing with cosine. If I take cosine theta and I add however many 2 pi's that I want, it's still going to equal cosine of theta. Okay. So in order to make our lives easier, we take our theta if it's greater than 2 pi, and we're gonna bring it down to an angle that is between. So we want theta to be between 2 pi and 0, right? That's our goal here. And once again, for our degrees, 360 degrees or 0 degrees, right? So that we can easily evaluate it. And this will be more important when we use our unit circle and our actual values on our unit circle, because our unit circle is only between 0 and 2 pi, or 0 degrees and 360 degrees. So we're going to do what we know that we can do, and we're going to take 15 pi over 4, and we're going to subtract 2 pi until we get down to a theta that is between 0 and 2 pi. Okay. So quick check, right? 15 divided by 4, that's definitely more than 2. So you know this is more than 2 pi, right? I get a 3.75 there. So I know that it's more than a 2 pi, okay? So I'm going to take 15 pi over 4, and I'm going to subtract 2 pi from it. But remember, we need to have 2 pi in terms of a common denominator. So we can actually, on the side here, our denominator is 4. So I'm going to multiply top and bottom here by 4. Okay, and I'm going to get 8 pi over 4. Okay, so I'm going to subtract 8 pi over 4 here from my 15 pi over 4. And that will actually give me 7 pi over 4. Okay, so 7 pi over 4 now. So 7 divided by 4, if you want to double check and you don't want to use mental math here. Okay, 7 divided by 4, if I put enter, it's 1.75. That means it's less than 2, right, for the 2 pi. So this is going to be 1.75 pi, okay? So I know that I'm between 0 and 2 pi. So this is equivalent to 7 pi over 4. That's the same thing, okay? So to find sine, right, we want to evaluate each function for sine and cosine. To find sine of 15 pi over 4, that is the same thing as finding sine of 7 pi over 4. I'm totally running out of space here. Hold on. I'm going to move that there. And I'm going to get this out of here. Okay, there you go. Okay, so finding the sine of 15 pi over 4 is equivalent to finding the sine of 7 pi over 4. So I'm going to do sine of 7 pi over 4. That gives me negative 707. So 707 sounds like it might be like a square root of 2 over 2. So let's try that out. And the reason why I say that is because square root of 3 over 2 was like a 0.866, right? Yeah, there you go. So this is a negative square root of 2 over 2. Negative square root of 2 over 2. Okay. And then I'm going to do the same thing for cosine. So cosine of 15 pi over 4 is equivalent to cosine of 7 pi over 4. Okay, and cosine of 7 pi over 4 is 0.707. So it's the same number, but now it's positive. So now this is going to be a positive square root of 2 over 2. Okay. So you simplify down the angle and you bring it down to between 0 and 2 pi. So over here, for theta, okay, you have theta equals 32 pi over 3, okay? You have theta equals 32 pi over 3. So here's a trick that I'm going to show you guys. I know, and you might have figured this out yourself. You might have figured this out yourself. I haven't graded your worksheets yet, so I haven't seen your work quite yet. Well, you might have figured this out yourself. So if I have 32 divided by 3, okay, or I'm sorry, not 3. I have, so in this case, because our denominator is 3, right, that means that my 2 pi, right, 2 pi here is going to be, I have multiplied by a 3 on top and 3 on bottom, so I'll have 6 pi over 3, right? Okay, so I want to see how many 6s are in 32. How many times will I need to subtract 6 from it, right? So I want to know how many 6s are in 32. So I have 32 divided by 6. That's what I do. I do 32 divided by 6, and that's 5.33. So I know that there's 5 full 6s, 5 full 6s in 32, okay? So what I can do here to make my life easier is, since I know there's 5 full 6s, that means there's 5 full 2 pi's in my 32 pi over 3. So I can do 32 pi over 3 minus 5 times 6 pi over 3. Okay, 5 would be like the equivalent of my n here, right? And so this is essentially, this becomes 30 pi over 3, right? So I'm subtracting 5 revolutions of 2 pi in one single subtraction thing here, okay, in one single equation. So this will be 32 pi minus 30 pi, which is going to be 2 pi over 3. And I get my simplified angle right off the bat. And that's all because I took what would represent the 2 pi, right, 6 pi over 3. I took the numerator value and I divided the numerator of my given angle. And I figured out how many of those is in that numerator. And that's what tells me what to multiply by, that whole number right there. Okay. So here we have 2 pi over 3. So if I want to find sine of 32 pi over 3, okay, that is the equivalent of finding sine of 2 pi over 3. Okay, 2 pi over 3, I have sine 2 pi over 3 here, 0.866. I believe the last time we checked, that's the square root of 3 over 2. Yeah, 0.866. It's positive. That's important. So this is going to be a positive square root of 3 over 2. And then we do the same thing. Cosine of 32 pi over 3 is equivalent to cosine, of 2 pi over 3. Okay, so if I do cosine of 2 pi over 3, I get a negative 0.5. So that's going to be negative 1/2. Okay, so you have your sine and your cosine. Okay, And then you have situations like these right here, where you have use a calculator to evaluate the trigonometric functions. Be careful with the mode the calculator is in. So if you see this, if you see pi, that means you are in radian mode, right? So this is our radian. And then if you see your degrees, obviously, this is your degree mode. So before you do these three, you'll need to come in here and change your, oops, you'll need to come here and change your radians into degrees. I would suggest maybe doing these guys first, right? So notice these are not our perfect angles, the angles that we recognize from our unit circle, right? Like 2 pi over 3 or pi over 2 or, 7 pi over 4. Those are all angles that are on our unit circle. These are not. 12 pi over 5, pi over 9, 13 pi over 7. They're really not on our unit circle. And so we can get decimals for these. We're not going to get exact values like these guys that we were doing up here. So if we do cosine of 12 pi, oh, I did that incorrectly. 12 pi over 5, okay? We get point 0.309, okay? And we can leave it at the thousandths place. So this is going to be 0.309. And you can try the square root of 2 over 2. You can try the square root of 3 over 3. You can try the 1/2. It's not going to equal 0.309. So it is what it is. Okay. Sine of pi over 9. Okay. Why don't I give you guys 2 minutes and you can work through these and then we'll quickly check them. Okay. So I'll give you guys 2 minutes. And you guys can punch these in. Don't forget to change the mode before you move on to your degrees. Okay. So we should have gotten these guys right here. Okay, check them. And I would like a response in the participants window. Thank you, V2. I see your thumbs up there. Okay, thank you, Lumeria. Thank you, Nick. Thank you, Zan. Okay, thank you, Kai. Thank you, Juan. Thank you, Ariana. Thank you, Anthony. Thank you, Erin. Thank you, Will. Wally, thank you. Wally, I think you put it up. I think I saw it flash there. So yes. Okay, good. All right. So pretty straightforward, guys. It is really pretty straightforward. It's just remember the whole period situation for um uh evaluating angles that are greater than 2 pi. Okay, so let's do our summary real quick. Do yourself a favor and do our summary. Describe how you can use the period of a trigonometric function to evaluate values greater than 2 pi. Describe how you can use the period of a trigonometric function to evaluate values greater than 2 pi. So you can give me a 1 sentence, 2 sentence answer there.